All right, starting chapter 7, we get into applying the Pythagorean theorem. So we're going to cover today is explain the Pythagorean theorem and how it can be used. So a Pythagorean triple is a set of three positive integers, a, b, and c, such that satisfy a squared plus b squared equals c squared. The c value is the largest value. This is also called the hypotenuse in a right triangle. And a and b are the two legs of the two smaller sides. So in this triangle, we would have a, b, and c, where c is the largest side. Okay, example 1 says, find the length of the hypotenuse of the right triangle. So we know it's a right triangle. That means the largest side is opposite the right angle. So this is our c. And then we have a and b. So if we follow our theorem, a squared plus b squared equals c squared. When we substitute in, we would get 24 squared plus 7 squared equals x squared. And if you use your calculator, 24 squared plus 7 squared will give you 625. So it'd be 625 equals x squared. And then to cancel out a squared and get just x, we take the square root. So you take the square root of 625, which is 25. So x equals 25. In the checkpoint, we're doing the same thing. The hypotenuse is opposite the right angle, so that would be c, and the other two are a and b. So we have a squared plus b squared equals c squared. A is 12, b is 9, and x is c. So it'd be 12 squared plus 9 squared equals x squared. We get 144 plus 81 equals x squared. And then we do 144 plus 81 is 225. So 225 equals x squared. How do you cancel out a squared? You take the square root. And the square root of 225 is 15. So x equals 15 in this one. So that's when we're given a right triangle and you got to find the hypotenuse. Example 2 says a 6-foot board rests under a doorknob and the base of the board is 5 feet away from the door, the bottom of the door. So like this picture here in the bottom right, approximately how high above the ground is the doorknob? So here's the doorknob. We're looking for this height right here. So really our triangle looks like this. We have x, we have 5, and we have 6. So if we identify the biggest side, which would be opposite the right angle, that's c, and the other sides are a and b. So a squared plus b squared equals c squared. A is x, so it's x squared. B is 5, 5 squared. And c is 6. So x squared plus 5 squared equals 6 squared would give us x squared plus 25 equals 36. We subtract 25 to get x squared equals 11. And then to solve this, you take the square root of 11. So x equals the square root of 11. If you want to find this out, you would use your calculator. Square root of 11 is 3.3. It's roughly 3.3 feet above the bottom of the door. Okay, so sometimes we have to round these to decimals because they don't always come out the perfect squares. All right, and then checkpoint 2. A 5-foot board rests under a doorknob and the base of the board is 3.5 feet away from the bottom of the door. Approximately how high above the ground is the doorknob? So again, we have this door, and there's a doorknob here. And then we create this triangle where this board is 3.5 feet away. So this would be 3.5 feet. And the board is 5 feet, so it's a 5-foot board. And it's resting below the doorknob. Okay, and like, let's say here's our doorknob right there. So we're gonna find out how big is X. Again, the C value is opposite the right angle, so the C value is 5, and then we have A and B. So if we do A squared plus B squared equals C squared, we would have X squared plus 3.5 squared equals 5 squared. So if we do the math on our calculator, 3.5 squared is 12.25. And 5 squared is 25. So we get X squared plus 12.25 equals 25. So we subtract 12.25 to get X squared equals 25 minus 12.25, which is 12.75. And then how do we get rid of a squared? You would take the square root. So the square root of 12.75 is about 3.57. Okay, example 3, find the area of an isosceles triangle. So we're going to find the area of an isosceles triangle with the side lengths of 16, 17, and 17. So isosceles triangle means, two sides are the same, and we'll call our base is 16. So the area of a triangle is area equals 1/2 times base times height. And right now, the base is 16. We do know that. We have to find out what the height is. So what we're going to do is look at this green triangle. So that green triangle, if I draw it over here, we have 17, 8, because 8 is half of 16, and then we have H. So we're going to find H because we already know that B equals 16. We have to find H to find the area. So if we do that, our biggest side is 17, and then our other two sides are our A and our B, or will be our A and our B, which are 8 and H. So Pythagorean theorem would say that 8 squared plus H squared equals 17 squared. And again, that is because 17 is the biggest side and H and 8 are the smaller sides. So we get 64 plus H squared equals 289, and we would minus the 64 to get H squared equals 289 minus 64 is 225. Take the square root to get H equals 15. So now that you know what H is and you know what B is, we can plug that in. Area is 1/2 times 16 times 15. So the area of this triangle would end up equaling 120, and this would be in meters squared. So that was tricky because we had to find the height first, and then we had to use the height to find the area of the triangle. So there are multiple parts to this. Use Pythagorean theorem to find the height, then use the height to find the area. Okay, and if you have to pause or something to catch up, by all means do so. This box right here just is the common Pythagorean triples. You might find it helpful. It says to memorize these. You don't have to memorize them, but over time you're going to realize that, yeah, 3, 4, and 5 is a Pythagorean triple. It comes up quite a bit. 5, 12, and 13 is a Pythagorean triple because 5 squared plus 12 squared equals 13 squared. Same for 8, 15, and 17, 7, 24, and 25. So all those are Pythagorean triples. And then notice that each row below are just multiples, right? If you double it, you'll get 6, 8, and 10. If you double the circle above. If you triple this circle, you would get 9, 12, and 15. So these are all just multiples of the top row of Pythagorean triples. Okay, and we have a few more problems. Example 4 says, find the length of the hypotenuse of the right triangle. So if we want to find the length of the hypotenuse, the biggest side is x. So A and B will be our other two sides, 45 and 24. So we would have 45 squared plus 24 squared equals x squared, and we're trying to find x. Now, if you use this chart and you look above, do you see anything with 45 and 24? If you look right here, 45, 24, and 51 are a Pythagorean triple. So if you look at the box, we could say, oh, well, x has to equal 51 because 45, 24, and 51 are a Pythagorean triple. So you don't even have to do the work because you can look at the chart here and see that. So if you have these memorized, you can do the otherwise, just show the work and solve for the missing part. All right, check point 3 says find the area of the triangle. To find the area of the triangle, we have to find h. To find h, we have to kind of split this triangle apart, which we would have h, 50, and this would be 14. So 50, 14, and h would be 50 is the biggest, so we would have 14 squared plus h squared equals 50 squared. 14 squared is 196, and 50 squared is 2,500. Okay. Subtracting 196 to get h squared equals 2,500 minus 196, which is 2304. And then to get h alone, we take the square root. So h equals the square root of 2304. H equals 48. And then we'll use our equation. The area of a triangle equals 1/2 times the base times the height. So the area of the triangle is 1/2 times 28 times 48. 1/2 times 28 times 48 is 672. So the area is 672 feet squared. And again, that was like the problem above where we had to find the height with Pythagorean theorem and then find the area of the triangle. Okay, and the last problem says find the missing side length. The missing side length is x. That is our biggest side. So our formula would be 30 squared plus 40 squared equals x squared. So we could do the math, or if we look above and see if we find something with 30 and 40 in it. So we scroll up right here, 30, 40, and 50 are a Pythagorean triple. So since 30, 40, and 50 are a Pythagorean triple, we know that x has to be 50. Because together, to make a squared plus b squared true, we have to have 30, 40, and 50 together. All right, so that's how we use Pythagorean triples. All right, and that's all we got. I will see you in class tomorrow.